State and explain Beer-Lambert's law. Mention its limitations. Beer-Lambert's law states that when monochromatic light passes through an absorbing solution, the absorbance is directly proportional to the concentration of the solution and the path length of the container. It is mathematically expressed as A is equal to ECL, where E is the molar absorptibility, C is the concentration, and L is the path length. This law is widely used in quantitative analysis using spectroscopy. However, it is valid only for dilute solutions as higher concentrations cause molecular interactions that affect absorbance. It also requires monochromatic light and constant temperature for accurate results. Deviations may occur due to instrumental or chemical factors. Discuss the types of electronic transitions in UV visible spectroscopy. Electronic transitions occurs when electrons absorb energy and move from a lower energy level to a higher energy level. In UV visible spectroscopy, the main types include sigma to sigma star, N to sigma star, pi to pi star, and N to pi star transitions. The sigma to sigma star transition requires high energy and is seen in saturated compounds. The N to pi star transition are most common in unsaturated and conjugated systems. These transitions are important for analyzing molecular structure and chemical properties. Explain the vibrational modes of CO2 and H2O. Vibrational spectroscopy is based on the absorption of infrared radiation, which causes molecules to vibrate. For a non-linear molecule like H2O, the number of vibrational modes is given by 3n-6, resulting in 3 modes: symmetric stretching, asymmetric stretching, and bending. For a linear molecule like CO2, the number of vibrational modes is 3n-5, giving 4 modes. However, the two bending modes in CO2 are degenerate, meaning they have the same energy. Also, the symmetric stretch in CO2 is IR inactive, and it does not produce a change in dipole moment. These vibrations help in identifying molecular structure. Describe the principle and instrumentation of sun. Scanning electron microscopy works by scanning a focused beam of high energy electrons over the surface of a sample. The interaction between electrons and the sample produces signals such as secondary and backscattered electrons, which provide information about surface structure and composition. The main components of SEM include an electron gun for generating electrons, electromagnetic lenses for focusing the beam, a vacuum chamber to prevent interference, and detectors to collect signals. The output is a high resolution 3-dimensional like image. SEM is widely used in material science and nanotechnology. Distinguish between temporary and permanent hardness of the water. Hardness of water is due to the presence of dissolved calcium and magnesium salts. Temporary hardness is caused by bicarbonates of calcium and magnesium and can be removed by boiling, which converts them into insoluble carbonates. Permanent hardness is caused by chlorides and sulfates of these metals and cannot be removed by boiling. It requires chemical methods such as ion exchange or celluloid process. Temporary hardness is easier to remove compared to permanent hardness. Both types affect the efficiency of soap and industrial process. Explain the ion exchange process for water demineralization. The ion exchange process removes dissolved salts from water using synthetic resins. In this process, hard water is first passed through a cation exchange resin, which replaces metal ions like Ca2 and Mg2 with H ions. Then the water passes through an anion exchange resin, which replaces anions like Cl and SO4 with OH ions. The H and OH ions combine to form pure water. This method produces highly purified water and is widely used in industries. The resins can be regenerated using acids and bases, making the process economical. What is reverse osmosis? Explain its use in water purification. Reverse osmosis is a water purification process that uses a semi-permeable membrane to remove impurities. In this process, pressure greater than the osmotic pressure is applied to force water from a concentrated solution through the membrane. Only pure water molecules pass through, while salts and contaminants are left behind. RO is effective in removing dissolved salts, organic substances, and microorganisms. It is widely used in drinking water purification and desalination. This method is efficient and does not require large amounts of chemicals.